Machine learning models face two main types of attacks that can compromise their reliability. During deployment, adversaries can subtly manipulate input data, like slightly altering a stop sign's pixels, to trick the model into making wrong predictions, a technique called evasion attacks. But the threat doesn't stop there. Bad actors can also poison the training data itself, corrupting the model from the ground up before it ever gets deployed. To defend against these threats, researchers use adversarial training to expose models to attacks during development, apply defensive distillation to make models more robust, and employ feature squeezing to filter out malicious perturbations, ultimately creating AI systems that can withstand real-world adversarial challenges. Now let's explore how attackers can fool an AI model after it's already been deployed. Evasion attacks work by making tiny, carefully calculated changes to an input, like a stop sign image, that are often invisible to the human eye. Attackers use sophisticated techniques like the fast gradient sign method and projected gradient descent to find the exact tweaks needed to trick the model into misclassifying what it sees. The result? A confident but completely wrong prediction, like identifying a stop sign as a speed limit sign, which is exactly the kind of dangerous failure we need to defend against. During the training phase, attackers can inject malicious data directly into your machine learning model's training dataset. This corruption acts like a Trojan horse. Once the poison data influences the model during training, it can cause the AI system to malfunction or behave unpredictably when deployed. Think of it like teaching someone with false information. The more convincing the lies, the more deeply they're internalized. By the time you realize the model has been compromised, it's already learned to make faulty decisions based on the attacker's deliberate manipulations. When you're building AI systems that need to withstand attacks, you've got to think like an adversary. That's where these 4 defense strategies come in. First, adversarial training exposes your model to hostile inputs so it learns to handle them, kind of like a security drill. Defensive distillation and feature squeezing work by simplifying how your model processes information, making it harder for attackers to exploit its vulnerabilities. And finally, robust prediction ensures your model doesn't just make accurate guesses, it makes them with real confidence, so you know when it's actually reliable. Together, these techniques create multiple layers of protection that keep your AI standing strong against real-world threats.